Well, here we are, ready for part one of cis204, Unix shell scripting and utilities, week 12. And just when you thought you were safe and getting away from awk, we're going to do some more awk. Oh boy. So without any further ado, let's get rid of this cheesy camera. And we'll jump in. Awk one more time. Last 2 weeks we've covered awk, and awk will be used in your Project 6 extensively if you're doing it right, or if you're doing it the way I did it. There's many ways to do it right, but you should be using awk in the projects, especially Projects 5 and Project 6, and of course those two projects account for 20% of your grade, so you want to have some idea of what's going on with awk. Awk is a good starting point to get familiar with other programming languages, in particular, as we've stated before, Perl and Python. So if you get comfortable with awk, you'll understand some of the concepts that you'll need to get comfortable with other programming languages, because awk is a programming language. It's a scripted language and not a compiled language, but it does some pretty powerful things, as long as you're not trying to do some really fundamental programming tasks. It does manipulate text very well. So, and again, that was the basis for buying the PDP 1170 when Ken Thompson needed something bigger to play space travel on. So, without any further ado, here we go. Awk again. Not that way. Let's do next. Okay. Quick review of week 11. Remember that you can set variables inside awk, and you don't have to declare the variable. The way awk works is it looks to see if it can interpret what you've given it. If it can't, it assumes that it's a variable. Now that is good and bad, but you do not have to declare variables. However, there are a number of internal variables and whose names that you don't want to trample on. And they are fs for the input field separator, nf that gives you a value of the number of fields that are on a record. Remember, a line of text is a record for awk, can be, and that's by default. Awk views a line of text as a record, and of course a line of text in the Unix environment is denoted by an new line at the end of the line, and that new line character is a $sign for our purposes. So there's a field separator. There's a variable that will give you the number of fields on a record. There is a variable that will give you the record number, or the number of records. There is a record separator. By default, that's white space, but it can be set to something else. You can also use that field delimiter outside the pattern action statement of awk. But a record separator, which in our case is a new line, and an output field separator. Okay. For example, awk output field separator equal t. There is a file out here somewhere. If I can bring up a terminal, let's see what I've got in here. It's week 12 files. So let's do week 12 underbar files. That gets us, where's the max? Where's Mr. Max? Well, I don't think I have a Mr. Max in here. Okay. But let's see here. Let me bring up another terminal. And let's see if we can find Max. Okay. Hang on just a minute here. So we get to this week 12, right? Okay. Let's do week 12 files. See what we've got in here. Where's Max? Max is not there. Okay. Well, that's kind of odd. I thought I had max out here somewhere. Okay. But let me go back and just kind of give you a summary of what's going on here. So the file max, and let me build a file max. That may be the best way to do this. VI max. Okay. So 12, 10, a 12, 10, 15, 72, right? And 08, 1, 56, 8, 92. How's that? There's a file called max. Now I can run this. Okay. So against max, I'm going to run an awk statement. After I clean up these Microsoft double quotes. So what am I asking this thing to do? Well, I'm telling awk, hey, before you do anything, change your output field separator to T, just T, not tab, and then print $1 and $2. Okay? What do I get? 12T10 and 08T1. So what does max have in it? It's got that. How do I print everything that's on there? Well, you want to print it twice? Here we go. But notice what it did with $0. $0 gave you the record as it appeared, not the record with the new field separator in it. So there you go, some fun stuff floating around in there. Okay. So another thing we reviewed or we covered was comparison conditional and computation expressions are available as well as logical operators. Very often, if you need to do math in bash, you know you can't do floating point, but you can do it inside the awk script. So that's one way to do it. Of course, there's the basic calculator if you want to go through that pain. But you don't want to do floating point in bash. It just doesn't like to do that. So you'll use awk to do math for yourself. So, like said, because awk is an improved sed to an extent, a range pattern can consist of two regular expressions separated by a comma. So if I want to find the first occurrence of Tom and do some action on the resulting records from Tom to, in this case, the first record that contains Suzanne, then it would do whatever action I had stuck on the other side of that regular expression of Suzanne. The other thing that can be done is you can increment and decrement operators. X++ is equivalent to x plus 1. X dash dash is equivalent to x minus 1. And you can do that before or after. You can increment or decrement before or after. So if I do an x++, that changes the value of x after the action. A plus plus x will change the value of x before the action. So that can be important. The other thing you may want to be aware of is the begin pattern is followed by an action segment that is executed before awk does any record processing. Also, the end pattern, as the name applies, is executed after all records have been processed. Every record gets processed, and then the end statement performs its action. Just as read works from the command line, the getLine function can be used to read input from standard in, a pipe or a file. And that would be some pipe or a pipe or a file other than the current file that's being processed. Reading user input, and you can read user input and assign it to a variable. And now we're going to jump into what we need to cover in the wrap-up session for awk. So let's look at the following example. Here I have an action where I'm going to set number, and the number is whatever field 6 has in it. This is an array that's being built for field 6. Now, why would I bring this up? Why would I say something about this num $6++? Would you believe that this is basically what you need to do to count the words in the Audi duty text for Project 5? This is very similar to what you're going to have to do to make that work. The reason I'm showing you this example is not because of this array. This is for var and num, print var occurs, num times. Print the variable occurs. So what's the var? Well, whatever's in $6, that's var. Okay, so $6 is var. See, num, this is num for var, which is $6, var, in num, and that is this. Print var occurs, num var is this accumulation of how many times $6 is found when that array is built. So if I find in AudiDuty.text the word the in any field 38 times, it would be the occurs 38 times. And then I could send it to an output file, and this is the reason for this slide. I could redirect the output to temp group. Okay, standard redirection can be done inside awk to another file. Notice, however, that I've got that file name surrounded by quotes. And in a shell, you're going to want to ensure that you have a fully qualified path to where that file is in the machine that you're working on. So I can do a while loop. I can do x equal 1 while x is less than or equal to the number of fields, print the number of fields, print the value of x, and increment x. So in other words, when I run out of fields, it will run out of the loop. So how about a for loop? For x equal 1, if x is less than or equal to the number of fields, and then increment x, and at some point it's going to be greater than the number of fields, well, then I'm going to print the number of the field number, and I'm going to print the value of x. Well, how about break and continue statements? Well, in this case, let's set x to 3, and when x is less than or equal to the number of fields, we're going to increment x. And so set x to 3, check to see if x is less than or equal to the number of fields, and then immediately afterwards increment x. So now it becomes x equals 4. Then it will look to see if x is less than or equal to the number of fields and set it to 5, and then it will come back. So in this case, the break is if the value of x is less than 0, then print bad and break out of the shell. Now what about the continue statement? So if x equals 3 and I evaluate x to see if it's less than or equal to the number of fields, and I increment x, and if x in this case becomes 0, I print next and I continue. So why would I do something screwy like this? Well, there's some fun things you can do with loops. So in this case, the while loop. So let me do this. Let's find the while test. So there is, where's my file while test? So here it is, while test, right? So I've got 1, 2, 3, 4, 5, 6, 7 lines. Notice I have 1, 2, 3, 4 fields, 4, 5, 6 field. All right, well, we'll see. 1, 2, 3, 4 fields in line 1. 1, 2, 3, 4 fields in line 2. 1, 2, 3, 4, 5 fields in line 3. 0 fields in line 4. 1, 2, 3, 4, 5 in line 5, 1, 2, 3, 4, 5, 6 in line 6, 1, 2, 3, 4 in line 7. Okay, so that's a file that has 7 records, and each record has a random number of variables or fields in it. So let me do this. Let's issue this statement, awk, and we'll print this. Okay, so what am I going to get? I'm going to get the record number and the number of fields in the record. How do I know? Well, remember back a few slides ago we talked about record number, that'll be my line number, and the number of fields. And this is a count of the number of fields in a line. So 1, 2, 3, 4, there they are. Line 1 is 4. Line 2 is 4. Line 3 is 1, 2, 3, 4, 5. So that's there. Line 4 is empty, so there are no fields there. Line 5 has 1, 2, 3, 4, 5 items in it. Line 6 has 6 items in it. 1, 2, 3, 4, 5, 6. And line 7 has 4 fields. Okay, that works. So now there is an awk shell out here. It's an awk script file. It's while.awk. And what am I going to do? I'm going to set a variable I to equal 1. And while I is less than or equal to the number of fields, I'm going to print the number of fields. I'm going to print I, and I'm going to increment I. Okay, so what is this? While.awk. So let's do awk-f while, while dot awk, and while underbar test. Okay, so what did it do? Well, it printed the field, the number of the field, and it printed the value, and then it incremented the value. So there are 4 fields in line 1, Bob, list, 298, that. There are 4 fields in line 2, 10, Dallas, 1, and there are 5 fields in line 5. I'm sorry, line 4, isn't that it? No, line 3. 5 fields in line 3. There are 5 fields in line 5. There are 6 fields in line 6, and there are 4 fields in line 7. Okay, well that worked pretty good. But did it really? What happened to line 4? Wait a minute. Line 4 has 0 fields. So if I set I equal 1, and then I say I is less than or equal to the number of fields, then how did I handle line 4? Well, I didn't. So how do I do this? Well, would you believe? Let's take a look at this one. While awk fix.awk. I set I to 0, and while I is less than or equal to the number of fields, I'm going to print that stuff. So let's go back here. While awk fix, right? Let's see if it picks up. There it is, line 4, 0. Now, even more fun, let's do this one. This will print the record number. Record 1, number of fields, 4. Prints record, the entire record. What does it print? It prints $0, doesn't it? Because I set it to I equals 0. And what field is 0? 0 is the entire record. So, boy, isn't this fun when this works. Anyhow, what a mess. But you can see how this thing lays out. Now, this is the end of part 1. You're going to come back and pick up part 2 momentarily.